Hello, Hashima. This video is for Monday, April 20th, lesson 90, data on a line plot. Today we're going to continue what you guys did last week, looking at line plots, which is a way to measure and display data. So let's just start with the facts, and then I'm going to go through two examples, one where you're looking at an already made line plot and one where you have to make your own. So fact number one, a line plot is a display of data similar to a bar graph. Fact number two, the distribution is how clustered or spread out the data is. So clustered is when everything is together, and spread out is when it's far apart. So for example, if you go to the store and there's a bunch of oranges all in a pile, you would say that they're clustered. If the oranges are spread out on the table far away from each other, you would say that they are distributed in a way that's spread out. So let's look at example A together. It says Mrs. May's class weighed several different tomatoes to the nearest 1/8 of a pound, and the results are shown in the line plot. So if you look at the line plot, what's being measured is the weight in pounds. And then all along the number line are different weights. So 0 pounds, 1/8 of a pound, 1/4 of a pound, 3/8 of a pound. And at each weight, there's X's. And each X stands for one tomato. And so, for example, if you look at 1/8, there are 5 tomatoes that weigh 1/8 of a pound. If you look at 1/4, there are 3 tomatoes that weigh 1/4 of a pound, 2 tomatoes that weigh 3/8 of a pound, and so on. So just by looking at this line plot, we can tell that most of the tomatoes are clustered below 1/2 of a pound. There's not that many tomatoes that are above 1/2 a pound. So just keep that in mind as we go through these questions. So first of all, what's being measured? We already said this. The weight of several tomatoes is being measured. How many total tomatoes are weighed? So in order to figure this out, you would count the number of X's because each X stands for one tomato. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 total tomatoes were weighed. Question 3, what's the total weight of all the tomatoes that are 1/8 of a pound? So I could either do repeated addition here and do 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8. Or I could just multiply 1/8 of a pound times 5 is 5/8 of a pound. That's the total weight of all the tomatoes that are 1/8 of a pound. These questions aren't that hard in terms of math, but it's tricky to figure out what the question's actually asking. Question 4, which describes how the weights are spread out. So are they clustered between 0 and 1/2? Are they clustered between 1/2 and 1, or are they spread out evenly? So when I look at this line plot, I see that most of them are clustered between 0 and 1/2. There are not that many that are clustered above 1/2. So the correct answer is A. They're clustered between 0 and 1/2 pound. Last one for this line plot. What's the total weight of all the tomatoes that are 1/2 pound or more? This one's a little bit more complicated. So really what you're going to do is only look at the tomatoes that are 1/2 pound or more. So there are 3 tomatoes that are 1/2 pound. So I'm going to add 1/2 plus 1/2 plus 1/2. Then there's a tomato that's 5/8. So I'm going to add 5/8 too. Then there's a tomato that's 7/8. So I'm going to add to that. So if you look at my equation down here, I did 1/2 plus 1/2 plus 1/2 plus 5/8 plus 7/8. Now notice, those are all different denominators, so I converted them all to eighths. So 4/8 plus 4/8 plus 4/8 plus 5/8 plus 7/8 is 24/8. The only reason I turned them into eighths is so that I could add them, and that gives us a total of 3 pounds because 24 over 8 is the same as 3. So the answer is 3. All right, in example B, you are making your own line plot. So it gives you 9 students that have a contest to see who can run the farthest. And the table right here shows all the different people and the amount of miles that they ran. So you had to come up with your own line plot. So when you make a line plot, you make a number line, which is what I did here. And in order to decide where it starts and ends, you need to first think about the smallest number on the chart and the biggest number on the chart, because you need your number line to have something below the smallest number and something above the biggest number. So I found that the smallest number is 1 1/4 and the biggest number is 2 1/4. So that way I made my number line show from 1 to 2.5, because that way all the numbers in the chart will fit. And then what I did is I divided it up evenly by fourths. So 1, 1 1/4, 1 2/4, 1 3/4, 1 4/4, which is the same as 2, 2 1/4, and 2.5. Once you do that, the hard part's over. You just go through each name on the list, and I like to put a little check mark after I put it on the line plot, and you put a little X where it is. Then the last question on the bottom says, what's the difference between the shortest length and the longest length on the line plot? So I looked for the longest length, which is 2 1/4, and the shortest length, which is 1 1/4, and I subtracted them. So that's how I got my answer of 1 mile, because 2 1/4 minus 1 1/4 is 1 mile. So this stuff is a little tricky. Do your best with this. It might be a little easier today since we did it last week, and we will see you on Zoom.